Unexpectedly, galactic events of extraordinary scale happen billions of kilometers from Earth, reverberating throughout the universe. As of now, a comparable event is approaching, causing shock even among scientists. A red giant star located at the outer reaches of our galaxy is sending ominous signals across the universe, detected by the James Webb Space Telescope. Cosmologists have revealed deeply unsettling discoveries about this legendary celestial body. As renowned astrophysicist Brian Cox issues a grave warning, a pressing question arises. Are we teetering on the edge of witnessing a catastrophic cosmic explosion that could forever alter the natural night sky? Before diving into further details, make sure to subscribe to our channel if you haven't already. Now, the burning question remains. Will this impact Earth, and will it be visible from our planet? Stay tuned as we explore the answers to these compelling questions in this video. In the vast expanse of the universe, where the spectacle of stellar birth, life, and death unfolds in mesmerizing splendor, one specific star has recently captured the attention and concern of both cosmologists and the general public. This star, known as Betelgeuse, stands out prominently as a red supergiant in the constellation Orion, boasting epic size and age. While its striking rosy hue and fluctuating brightness have long fascinated observers, recent events have further heightened interest in this majestic behemoth. As we delve into the essence of Betelgeuse, we find ourselves on the brink of a potentially spectacular event in the star's life cycle. But what do these changes in Betelgeuse's behavior signify? Could we be witnessing the dawn of a remarkable and grandiose display of unimaginable magnitude? Betelgeuse, with a size approximately 1,000 times greater than our Sun, remains a colossal giant among stars. Its sheer size stretches the limits of human imagination. Picture a star so massive that, if it were to replace the Sun, its surface would extend beyond Mars's orbit, engulfing Mercury, Venus, Earth, and Mars within its immense grasp. This extraordinary size not only underscores Betelgeuse's true gigantism, but also hints at its place in the cosmic life cycle. As a red supergiant, Betelgeuse is in the twilight phase of its existence, marked by expansion and cooling after a lifetime of fusing hydrogen into helium at its core. Questions arise about Betelgeuse's age. Despite being relatively young in human terms, estimated at around 8.8 to 8.5 million years old, it is incredibly ancient in the context of stellar lifespans. Its current status as a red supergiant reflects the culmination of millions of years of stellar evolution, characterized by dramatic transformations from a hot blue star to the magnificent red giant we observe today. The journey of stars like Betelgeuse unfolds as a narrative of constant change, driven by the relentless forces of nuclear fusion and gravity. One notable feature of Betelgeuse's current stage is its striking red tint. This deep red color arises from its relatively cooler surface temperature compared to stars like our Sun. While the Sun shines at around 5,500 Kelvin, Betelgeuse's surface is cooler, averaging around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light in shades of red. However, this coloration is not merely an aesthetic trait. It provides insights into the star's physical state and the ongoing processes within its vast gaseous domain. Adding to the intrigue surrounding Betelgeuse is its peculiar color history. Ancient records from Roman and Chinese sources suggest that nearly 2 millennia ago, Betelgeuse appeared yellow. It was only after the 9th century that Arabic scholars described it as red. This historical change in color is not just a reference in astronomical records, but serves as a marker of the star's transformative journey. The fluctuating brightness of Betelgeuse adds another layer of fascination. As a semi-regular variable star, its luminosity undergoes periodic variations. This dance of brightness has captivated astronomers and stargazers for centuries. Typically, Betelgeuse follows a 400-day cycle alongside a longer 5-year cycle, noted as far back as 1836 by Sir John Herschel and perhaps even earlier in indigenous oral traditions. Yet, what truly sets Betelgeuse apart is its unpredictability. Unlike many stars that follow predictable patterns, Betelgeuse sometimes deviates from its usual dimming and brightening rhythm. This irregularity points to complex and less understood processes unfolding within its enormous structure. Recent astronomical discoveries have captivated scientists and stargazers worldwide. When Betelgeuse underwent a surprising and dramatic transformation, now widely known as the Great Dimming, it caught everyone's attention. It all began in late 2019, when Betelgeuse, the red supergiant shining brightly in the night sky and a prominent feature of the Orion constellation, began to experience a mysterious dimming. The dimming was so pronounced that it lost luminosity at an average rate of 0.01 magnitudes per day, reaching its lowest brightness by February 2020. Betelgeuse, usually visible to the naked eye even amid light pollution, faded significantly, something even amateur observers couldn't miss. However, tracking Betelgeuse's activity poses a fundamental challenge: the time delay. When we observe a star like Betelgeuse, we are not seeing its current state but rather its past, due to the time it takes for light to travel to us. Betelgeuse, situated approximately 725 light-years away, is situated approximately 725 light-years away from Earth. This means that when we observe Betelgeuse, we're looking at light that left the star more than 7 centuries ago, so any changes we see are actually the result of past events. This time delay makes it all the more difficult to predict what will happen next with a star. Nevertheless, the Great Dimming has raised crucial questions and sparked much debate among astronomers. Could this anomaly indicate an impending supernova? Is the star shedding its outer layers? Or is there another underlying cause for this dramatic dimming? The answer remains uncertain, but one thing is clear: Betelgeuse is in a critical stage of its life cycle. Stars like Betelgeuse, which are massive and nearing the end of their existence, will eventually explode in a supernova, a cataclysmic event that releases an enormous amount of energy, briefly outshining an entire galaxy. If Betelgeuse were to go supernova, it would be a spectacular sight from Earth. Although it is too far away to pose any direct danger to us, its explosion could be bright enough to be seen during the day and could rival the brightness of the moon. Supernovae play a significant role in the life cycle of galaxies, as they distribute heavy elements throughout the cosmos, which are essential for the formation of new stars, planets, and even life. Therefore, the fate of Betelgeuse is not only of scientific interest but also an important event in the larger cosmic process. As we continue to observe Betelgeuse and its strange behavior, we may be witnessing the final chapter of a star's life that will have profound implications for the universe. In the coming years, astronomers will continue to monitor Betelgeuse closely, using both ground-based and space telescopes to study its every move. They hope to gain further insights into the mechanics of stellar evolution and the end stages of massive stars. Whether Betelgeuse will explode in a supernova or continue to evolve in unexpected ways, one thing is certain: its story is far from over, and it will continue to captivate both scientists and skywatchers for years to come. As for us here on Earth, we will watch, wait, and wonder. Could Betelgeuse's fate offer a glimpse into the future of our own sun, or will it provide answers to questions we've long pondered about the life and death of stars? Time will tell. Stay tuned as we follow this cosmic mystery, and don't forget to subscribe for more updates on Betelgeuse and other celestial wonders. Years away implies that the light we see today left the star almost 7 centuries prior. This time delay convolutes endeavors to anticipate and follow unexpected changes in a star's way of behaving, as we are basically seeing occasions that occurred in the far-off past. The diminishing of Betelgeuse's brightness serves as an unmistakable indication of the intrinsic intricacies in vast observations and the impediments of our comprehension while wrestling with the huge sizes of the universe and the time mystery. They include the dazzling journey of Betelgeuse's galactic presentation, which was fastidiously followed by Andrea Dupree, the associate head of the Center for Astronomy at Harvard and Smithsonian, alongside her group. Utilizing the Hubble Space Telescope, they set out on a 3-year study to monitor changes in Betelgeuse's external climate. These observations provided an uncommon understanding of how a variable star like Betelgeuse acts, with its normal extensions and constrictions, leading to vacillations in brilliance. The striking responsiveness of Hubble to bright light empowered the specialists to test the layers above Betelgeuse's surface, which were, in part, heated by the star's violent convection cells. Moreover, a definite examination of the Hubble spectra, taken at different spans throughout 2019 and 2020, worked with the estimation of material development inside Betelgeuse's external climate. Specifically, the study focused on the magnesium-2 lines in the spectra, which offer insights into the star's barometric conditions. These observations revealed material moving at speeds of around 200,000 miles per hour from Betelgeuse's surface into its external climate. This heated and dense material ultimately extended thousands of miles from Betelgeuse, forming the precursor to the dust cloud responsible for the star's darkening. Dupree and her team estimated that during the 3-month event, approximately twice the standard amount of material from Betelgeuse's southern hemisphere was shed. This significant mass loss is especially notable because, like all stars, Betelgeuse continuously sheds mass, but at a much higher rate than our Sun. The magnitude of this mass launch and the subsequent dimming sparked discussions among cosmologists about whether this event could signal a looming cosmic explosion. The proximity of Betelgeuse, located approximately 725 light-years from Earth, adds to the intrigue. If such a blast were to occur, it would be visible from Earth, presenting a captivating opportunity to closely observe a supernova explosion. Yet, the question persists. What does this darkening event mean for Betelgeuse's future? Does it signal an impending cosmic explosion, or is it just a transient stage in the star's immense and complex journey? Different theories have been proposed to shed light on this phenomenon. One hypothesis suggests a stage in the cosmic explosion process, gaining traction due to the widespread belief that Betelgeuse is nearing the end of its life cycle. Another widely accepted theory involves dust, possibly originating from the star itself, obstructing our view of Betelgeuse. A third explanation examines changes in the star's photosphere, its apparent surface layer, which could affect its apparent brightness. Exhaustive analysis using various observational techniques contributed to unraveling this mystery. Spectroscopic evaluations showed a reduction in Betelgeuse's effective temperature, indicating the possibility of a significant dark spot on the star's surface. This hypothesis found support in observations revealing a temperature decrease of at least 170 Kelvin during the darkening period, highlighting significant surface changes. Ultimately, the key to understanding this exceptional phenomenon came from humanity's careful gaze into space, the Hubble Space Telescope. Hubble's precise observations revealed that Betelgeuse's dimming was likely caused by a significant release of heated material into space. This material coalesced to form a dust cloud, blocking part of the star's surface and reducing the amount of light reaching us from Betelgeuse. The formation of the dust cloud was attributed to superheated plasma, which erupted from a large convection cell on the star's surface and passed through its burning atmosphere to the cooler outer layers. After cooling, this plasma formed dust particles, resulting in a cloud that blocked light from about a fourth of the star's surface. Hubble's ultraviolet light spectroscopic observations, which began in January 2019, played a significant role in reconstructing the timeline leading up to Betelgeuse's dimming. These observations detected signs of dense, heated material passing through the star's atmosphere in the months preceding the dimming event. By December 2019, other ground-based telescopes also observed the star's reducing brightness, especially in its southern hemisphere. Initially, this material appeared brighter than the star's usual iridescence, eventually culminating in the formation of a shadow as it dispersed outward and cooled. The idea was straightforward. This outward progression of material and the subsequent shadow were responsible for the sudden dimming of the star. The scale of this launch is truly remarkable, pushing Betelgeuse into the astronomical spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This expelled material was thought to be enough to cover our moon several times over, marking a significant event for Betelgeuse, as well as advancing our understanding of celestial mechanics. But what are the implications of such a massive release of material for Betelgeuse and the broader theories of supernovae? Traditional thinking suggests that red supergiants like Betelgeuse typically shed mass before reaching the destructive peak of their existence. However, the size of this release challenges this notion, indicating a potentially more unstable and erratic final stage for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion within the next few centuries? Later research speculated on the timing of such an event, suggesting it might occur sooner than previously expected, perhaps in just a few years. Furthermore, the concept of the bow shock adds another crucial layer to the Betelgeuse puzzle. As this colossal star races through space at around 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock, similar to the wake formed by a boat's bow. This phenomenon arises from the star's outer layers interacting with interstellar gases and dust, providing a spectacular display of the star's dynamic behavior and its interaction with the galactic medium. But what about Betelgeuse's recent behavior? Its surface cooling and reduced density, observed following the ejection event, leave the star in an agitated state, even years later. Hydrodynamic simulations suggest a connection between the star's convective activities, the mass ejection, and the subsequent changes in its oscillation modes. This ongoing instability raises questions about the internal processes driving these changes and their potential implications for the star's future. Moreover, the observed mass loss rate of Betelgeuse surpasses that of many other stars, reflecting a complex interplay of internal forces. By interacting with energy dispersing through shock heating and mass ejection, Betelgeuse's mood is shifting. The very nature of these mass losses points to the star's dynamic and somewhat unpredictable life cycle, prompting astronomers to reassess their models of stellar evolution.